You demand for IP reuse. IP can no longer be developed and verified outside of context of a system in which it is expected to operate, unless we develop new verification methodology. Experts at the table, semiconductor engineering, sat down to discuss our state-of-the-function verification with Mohan Dane, director of for the architecture and design at Alphawave Semi, Andy Nightingale, vice president for product management and marketing at Arteris, Dinesha Rao, senior group director for software engineering at Cadence, Chris Mueth, is a new opportunities business manager at Keysight, Gordon Allen, director of verification IP product at Siemens CDA, and Frank Rumister, executive director for strategic programs and system solutions at Synopsys. What follows are excerpts of that discussion. Part 1 is here. The value, okay, is a C. The error, the C. System level verification is often left until the end, but does shifting left means that hardware software verification is becoming more important, and will that more reliance on things like virtual prototypes. The general purpose design is being replaced with custom design with specific workloads. This means that someone who is verifying hardware should be understand the software that runs on the hardware. That having this requirement known is going to a problem. If you look at the latest associates with AI ML technology, most of them have the requirement of software being validated during silicon development. This puts pressure on tools to improve the methodologies and workflows be reworked and rebuilt. This is putting a lot of stress on teams, and everyone is being stretched a bit thin. In terms of tools and methodologies scenario, we are not innovating. There is a lot of innovation that's happening. If you look at the space of software and hardware co-design, emulation with a focus on hardware debug and prototype with a focus on software debug, these have all made significant progress. Similarly, in the forms of verification space, in this era of the domain-specific architectures, there is an explosion in a processor design. Pretty much all of the former solutions are scaling to address the space. I'm cautiously optimistic. It's just that a requirement that are scaling at such a high pace, and we are in a catch-up mode. The Nightingale verification is scaling in the different and the decision at a different rate is because of the false software. You've got virtual platform for early software to bring up, which are absolutely crucial. Even though that was scaled up, and you can get on to an AWS server, grab a virtual platform, dump on an OS on it, get it to the boot. You can interact with all elements in the design and see how the different bits of software interact together, which is great. However, what gets missed is the fact that we haven't shifted fast enough, in order to catch the protocol level errors and interaction issues between pieces. The verification community needs to shift left a little bit more for the software that's making a transaction somewhere is not missing the fact that in invalidating a protocol, the software runs everyone happy and they move on. On the hardware side, you just send a potentially invalid protocol, but it is not seen at that abstraction level, or the arbitration mechanism has been violated in some way and not flagged. Your software runs on the virtual platform. you implement that in the hardware, and you can get an arbitration issues. Why has my software performance tanked? Well, because we haven't seen them before, and because the verification methods that were used before were sufficient. Now we've hit a tipping point in the complexity where you're starting to check some cracks. Now we have to scale the verification at the same rate. Sure, Minister. Sure, Mister. For IP verification, the list of requirements itself is complicated, but it's working reasonably well. Nightingale, this is a bounded problem. Sure, Meister. Then the next one, because complexity moved up, and the design moved up as well. Now you can have an ARM CSS or any source system, and you have 3 different versions of PCI Express. That's your source system. Now the source system ends up on a chiplet, on a SoC, something which becomes a multi-die. Then I have the actual multi-die system within each context. So the challenges that you are working on happen after 10 minutes of the real time. Emulation won't help you there. You really want to be smart about how you find the coherency issue. Coherency is one of the really main problems that happens after quadrillions of cycles. The verification problem we are talking about is really at that integration point. Then you have system issues and thermal issues. But your chip works fine until you integrated it, and that adds another dimension. Schulmeister, and 15% from the survey probably comes from these issues at the system level. Well, verification was not done early enough. It hasn't been shifted left, but you really need to consider the scope of which type of error you actually find. Then, I believe use. What we kept telling people is being challenges in the sense that IP is developed based on the requirement of a particular system. But when it is getting reused, that's when all the challenges come, especially in different subsystems. That's where it is put under a lot of stress. Reuse has to be looked at, because it takes a lot of effort to get that IP working in different systems. Now, from the methodology perspective, the traditional method of verifying an SoC starts at the IP level, then the subsystem level, and the full chip level. That's typically our workflow. But now, with different engines working on different data sets at the same time, like ARM CSS, the way it works is different. With a chiplet, there are many different types of transactions happening within a system, and that makes it difficult to simulate at the IP level. Your target IP for IP level test cases. But you need to bind these test cases with the actual SoC spec. That is your real target. But the SoC spec doesn't cover all the transactions you need, because the spec will only tell you what it is supposed to do. But in what critical scenario, is very difficult to predict at the time. If you have multiple power domains, then with some of the dynamic power saving utilities that you can create, the design you have created, and all these channels that you have implemented based on some transactions happening somewhere, you miss one of them in your spec. The DV engineers won't be able to generate that test case. It's not possible. The spec needs to exactly specify all the scenarios, which is very difficult. That's why you have emulation where you can run your system level test cases. You were able to do the certain things, but the spec silicon schedule is shrink. In the past, the schedule for each chip used to be a 2 to 2.5 years. It is shrinking. Now we are talking about a 9 months to 15 months tape-out schedule. That's very aggressive. If you have an army of people verifying some features will get through the gap, that's where we are finding the issues. We need a solution that basically makes your spec as complete as possible. Right now, that is very difficult. That's why we need a tool that can come up with the spec and accordingly create a verification environment for that. We need a solution that basically makes your spec as complete as possible. Right now, that is very difficult. That's why we need a tool that can come up with the spec and accordingly create a verification environment for that. This is basically creating a test suspension verification strategy at different level, IP level, subsystem level, and full chip level, and multi-chip. Multi-die is coming into the picture, and the complexity is growing exponentially. We need an AI approach, and that is at the upfront spec level to verification. That gap is where we see the issues. Let's see. That's scary because the design is also going to be driven by the spec. Now if you're driving the test bench generation automatically from the spec, that has violated the principle of the verification. You need two things that are independently developed and compare against each other. Schurmeister, they shouldn't be the same. With is independence, but the spec is supposed to be a source of the truth. Alan, the granularity is changing with the chiplet economics. Assuming that to continue the same trajectory, we'll have a wholesale shift in the granularity of our architecture decisions. For maybe 80% of the SoC or SIPs, they will be reusing more trusted element. The true trust will be built in, the security will be built in, and the bounded IP verification will be required for that composition. But once we get there, we'll have a different set of architectural decisions to make at a different level. That will take us to the next level. Now you're right about tools. AI can equip us to deal with the complexity, but in some respects, we are dealing with that by changing the game, changing the granularity, embracing chiplets as embraced ICs and printed circuit board 50 years ago. The Lego brick has a different form. As ADA, we are investigating in that, but there is a long-term investment. We also need to take care of low-hanging fruit now. We are in this complexity cycle, and we are taking care of things such as the last 10% of coverage closure. That's the problem we've solved for a customer pushing the boundaries of today's problem. That's the productivity problem that customers are hitting. Pushing the boundaries of the data and today's technology, we are investigating both the low-hanging fruit for today's problem, but we are also acknowledging we are in this upcycle of a cyclical industry. Next 10 years, we are gonna be so exciting with what is to come, and it's on all of us to invest in that so that we are ready for it. Schurmeister, we had this discussion 20 years ago, saying verification engineers need to be different from designer. We need to have a separation concept. We create the problem. Many researchers are talking about automatically generating RTL from spec. I show the constant that is not corrected by construction, because the way we create the spec is never so dense and correct everything the spec says is golden. How do we get out of it? We got just to create a new race, but both races are AI enabled. We are creating more designs with the AI agents. Now we need to have another layer of verification to make sure that what the creates within the system context is verifiable correct, and for that we need a different, there you go, independent party. We certainly need a step change if we are gonna keep up with what AI is doing on the design side, and we can't use exactly the same thing for the verification. Schurmeister, from the survey, we need to know about the breakdown of the 50% potentially by technology nodes. Are those 3 nanometer designs? Are they 7 nanometer design? This concentrate in the most advanced design, those trailblazers. We need to worry about those. We need to figure out methodologies to verify those and make sure they work. But is there a class of the designs bifurcation in verification? Is there a set of the designs that we are not the data center mega designs? What about the smaller designs, and what about the subsystem? We need automation to close the gap. Automation for some of those components like processor verification and like the subsystem verification. There's automated techniques out that work. We have invested heavily in processor verification. With the number of processor variants emerging, we invested into automatically verifying those processor variations. But that is a very limited scope. How does the processor work if I created 64 of them connected by NFC? How do I figure out the current issues? That becomes the next level problems. Whenever I go to customers talk about automation technologies, and the IP archives are very happy, it helps them automatically get more test cases, just like constraint random helped us. The problem with the currency is if I have automated tools that generate lots of tasks, so that the debug is so difficult to find that this tool runs for days without finding any bugs. We have different scopes to consider for verification, I hope, for on the I side and the system side. But for the system side, and there are lots of work to be done. Then most of the time, and we are look at both, and IP is very well tested and they come into system. If you start running a similar set of versus test on those, which are the well defined, and you will find entry level bugs in any of these IPs. You need to look at the tools like PSS, where you can automate test generation, create thousands of tests to get a jump start on the SoC. That's where you will start looking at issues that are boundary issues or that are hiding within the cracks in your design. These are new technologies that our film industry should start looking at. More and more adoption of technology like portable stimulus, which really accelerates the verification. Okay, like today, this is the article from the Primary, the new demand for IP use. Thank you for your time. See you next time.